Hi everyone, I'm here again, so it's me again. So I'm going to talk about this topic, the only disaster recovery talk in this conference today, this time. So it's about testing for DR failover testing. I hesitated a bit about making it a shorter title, calling it just testing DR testing, but I figured it's a bit cryptic. So yeah. So that's it, and that's me. I think most of you have seen me yesterday. So let me start with the problem. Actually, I call it the parent problem, which is not the real problem, but the problem that caused the problem that we're trying to solve here. So this is disaster recovery failover testing. So this mostly applies to, again, in my small team context. I mean, we are running our entire backend infrastructure within a single data center. So we're asking the question, what happens if that data center is cut off, is down, right? Do we have a strategy to recover? So disaster recovery failover testing is about trying to test whether your system can be able to be failover from the current production data center to a DR data centers. Of course, the assumption is that we have a DR data center running, DR environment running in another data center that we can failover to. So that's about it. So it's a specific type of, I don't know how to pronounce this word, dirt. This is from the SRE book, Disaster Recovery Testing, so that Google did, and it's a small subset of it. And it's part of our, what we call the BCDR project within Zendesk, Business Continuity and Disaster Recovery. So our focus here is that we want to test the case whereby the data center is lost. The data center that is hosting our production environment is lost, and what do we do? Can we failover? We have a DR environment running in another data center, so we want to be able to see whether we can switch over to the other data center, and still continue to run the system. And we're only testing about customer-facing features. So that means we are excluding whatever internal tools that developers or other people, internal users might be using, but if those things are not available for after the DR failover, we don't really care that much about it in this particular context. So this is the parent problem. So I mean, a bit of elaboration on why we care about doing this. We have been running fine with a single data center, and it has never been a problem, but why do we want to talk about this? So this comes back to the compliance issues. One of it is, one major factor is the compliance, that we have this, again, this SOC 2 compliance. So as part of SOC 2, it requires the companies who conform to SOC 2 to have done twice a year disaster recovery failover testing. So this is part of the static requirement, so you have to do that. And we have some enterprise licenses that we promise the customer that if they purchase this particular security add-on, they have certain level of some certain guarantee about recovery time objective, 8 hours, and a recovery point objectives. So these are some gross jargons, but recovery time objective means that from the time the data center is down until the time that the system is up again from another data center it takes about up to 8 hours. And the second metric about recovery point objective is that from the time that the data center is down, how many hours of data you would have lost. So basically it means that we have kept almost a real-time replication of the data from the production data. So at any moment when it's cut off, we still have all the data up to that moment. So 0 hours is a pretty strict requirement. So also testing to verify the procedures and for DR failover, identify gaps and so on. So these are reasons why we want to do DR failover testing. And indeed, we did a few attempts to try that. And we have 2 exercises for DR failover testing in the past, and that resulted in 4 DR failover tests. So the reason why we have these 2 different numbers is because in the first testing exercise, it took us 3 times to get it right. So, and then of course the second testing exercise, we did it within one try, but the first time it was a bit scary. We schedule one and then try it, fail halfway, we back off, and then inform customers again, like 1 month later, we're going to do this again, and it failed again. So it's only the third try that we managed to get our first ever DR failover testing done properly. So, meaning that we cut off, switch to the DR data center, test for a while, and switch back to the production center, data center again. So 3 times to get it right for the first time. So, and even though we've done it 4 times, we encountered various issues in the past, like infrastructure, database not working, networks not working in the DR environment, and configuration in the DR environment, applications could not handle failures, couldn't handle the failures in the infrastructure, and it just like back off and could not panic and could not handle it. So some examples of issues that we encounter in these exercises. So we have customers being double billed because we have scheduled jobs running on both data centers. So easily imagine, right, the scheduled job in the production data center happily billing customers, and then when we fail over, the DR environment is also happily billing customers, we double bill the customers. So that's one example, and like our iOS app somehow requires a special configuration that in production environment that we didn't replicate into the DR environment. And because we didn't test the environment, we didn't know, and we only knew that when the customer informed us that, oh, you guys were doing this DR failover, right? But my iOS app is not working. So then we discovered, oh, this thing is not working. And there's another weird case whereby we fail over to DR environments, and then by the time we want to switch back to the production environment, we discover that there's a huge lag in terms of the MySQL replication from DR database back to the production database. So it's like an 8 hours gap or something, so we couldn't really switch back because the data in the production data, the data in the original production environment doesn't have the latest data in the DR environment yet. So we can't switch back. If we switch back, we will lose some data that we just newly added into the DR environment. So it took us a while to fix the issue. So that comes to us, the real problem that we're trying to solve here, which is that can we increase our confidence in doing our DR failover testing? So it's a bit, you have to twist your mind. But so what we're trying to do here is that we're going to do something so that we can have more confidence that the next time we do the DR failover testing, it is going to be a success. Like there won't be as many issues as it used to be, or there'll be 0 issues, it will be the best. But at least, please, fewer issues, right? And no major issues, and so on. So we are going to, that's why I call testing for DR failover testing, because we're going to test the environment so that we have high confidence in the next time we do the failover testing, it will work. So that's a real problem that I'm trying to solve here. So the answer is obvious, right? You just test it, right? Because if you don't know whether it works or not, you test it. So we want to test the DR environment while it is still in standby mode. So surprisingly, that gave us a lot of challenges. So of course, the ideal scenario is that we run automated testing while the DR environment is still in standby mode, and then we just run exactly the same set of browser tests that we run against our production environment. And we run it every time there is a change, either it's a new deployment to the codes, or either ops makes a configuration change, we just run the test again. So this is the ideal scenario, which, as you see, never happens. So the first issue that we encounter is that most of the tests inevitably involve writing data into the database, which in a typical scenario, you don't want the application to update the database in DR environment, because the only change that you want to bring into the databases, the data stores into the DR environment, are those that are replicated from the production environment. Right? You don't want to have some other extra changes that you someone writes some additional data in it, because that's going to cause a problem if you have to replicate the data back into production environment. So then we asked, can we just run, let's select the subset of the tests that are read-only and run them? But there are only very few of them, so there's not even an option to go with. So to us, the big question that we want to ask ourselves is that, should we do we allow direct writes into the data stores in DR, things that are not coming from replication, but really from the application itself. So this is a big question that we keep on asking ourselves. And yeah, so that's a big question. Should we allow direct write into the database data stores? Database, MySQL, like Elasticsearch, Redis, and all these different databases, data stores. So again, the big question. So what eventually we figure out is that it is a trade-off between two different risks. So allowing the apps to write into the database in DR, it actually introduced a risk of production failure. So this is, depending on your configuration, this could be like production will fail immediately, or it could be like when you fail over to DR and then fail over back, that production environment will fail because of the data inconsistency or replication conflicts and so on. So there's a risk of production failure. But if you don't do that, you sacrifice things like test coverage and try to just do a minimum test and declare that it's working, then you risk failure when you do failover. So it's a trade-off between like balancing the two risks. You can declare that, okay, I don't care about DR failover, it's a rare event, so I just want my production and DR environment stay the way it is now. Then yeah, you go for the first risk, like minimizing the first risk, and then don't care about the second risk, then yeah, you're fine. Or you can say like I think that it's likely going to be an earthquake in the next month, and then I want to make sure that my data center is okay, I can fail over easily, so then you choose to optimize for the second risk, but then somehow you have to give up certain things in the first part. So there's a trade-off. So a bit of background about the chat architecture. So we have all the JS and HTML as the front end. And then we have this middle layer called mediators, which resides everywhere globally around different regions in AWS. So these are like mediator proxies, servers that connects between the front end and the back end. And the real things that we have been talking about here is that there's this bunch of back-end services plus the data stores that we host in the data center, right? So this is the things that want to fail over, right? So you think about a scenario of a failover, DR failover, is that we want to cut off the link from the mediators, which is all over the different regions in AWS, and cut off that connection, and then switch to use the things from the DR data center. So this is as simple as it is. So everything here is sort of like a black box if you just talk about DR failover testing, right? So we have a bunch of apps, and then they connect to different multiple data stores in the data center. But when so now you need to look at what is inside data center, right? So in the simplest version, we have a bunch of services, and almost all of them access the data stores via the data API service. So we just really need to care about the data API service, which access things like Redis, MySQL Server, React, and Elasticsearch, and Memcache. I think we don't have to worry about it. So a bit of more information about the different data stores that we have, like MySQL database. We run like master to slave replication from production to DR, and DR is sort of like a read-only slave. And this is the part that we are least confident about whether it's going to work or not, right? Because by nature it holds like the majority of the data that we have in this moment. So things might go wrong, and it might cause data corruption and so on. So and then we have React, which is a thing that we don't worry a lot about because we have some sort of commercial license from Bashel that supports multi-data center replication and so on. So it has a commercial license. So we don't really worry about that, and it didn't give us any problems in the past few attempts for DR failover. And then we had Elasticsearch, we thought it's like we can handle it. And in worst case, we just rebuild it from the source of truth. So it doesn't hold any source of truth data. So worst case, we rebuild the data from MySQL, and it will still work. There's no data lost. And Redis, ephemeral data, we don't worry about it. Memcache, there might be a cold start issue, but we can take care of that. So as you can see, the main component that we might be worrying about is actually just MySQL database. So let's talk about different approaches. So the one piece of good news when we study this problem is that our applications happens to partition all the data by accounts. So that gives us a chance that if we set up if we create test accounts on the production environment and let it replicate, so we end up with a bunch of test accounts in the DR environment. And then if we declare that we are not going to touch these test accounts on production environment and only use them in the DR environment, then in theory, there's no chance that this test account, the data for these test accounts will be updated or modified on the production environment. So the only change that will happen to this data belonging to the test accounts will only be happening in the DR environment. So in theory, there shouldn't be any replication issues because you're going back and forth. You are almost guaranteed that there won't be any replication conflicts when you sync here and there, back and forth. So this is a very important assumption that we're having. And so with that assumption, we have investigated different alternatives about how to do that. So of course, best things that we avoid writing to the real DR databases. But can we do that? So if not, can we just allow writing to the less risky databases, like not MySQL, but some other, the rest? And finally, if nothing else works, then we just allow writing to all the databases and figure out a way to get around it. So this is the first configuration that we explored, and we set up a parallel set of test data stores, servers for each one-to-one, and configure the apps to talk to this set of test data stores instead of the real ones. Like we have another test Redis, another test MySQL server database, and so on. So and just right before we do the failover, we switch back to point to the real ones. So the drawback of this is that there is no guarantee that the connection between the apps and the real data servers, whether the connection is going to work or not, you don't know because there's no test that covers that. All you are doing is testing, trying to connect to the test database and test servers, right? So this was not an option. We ruled that out. So the next thing that we try to propose is that since the connectivity check is sort of important, why don't we just host two different databases on the same physical server? So you can apply tricks like if you have an account DB database, then you just put a prefix like test_account DB, but both databases reside on the same MySQL database server, for example, and things like Elasticsearch index or Redis queue and so on. This all could be solved, and you just need to update the library and everything else will work. So that covers the physical connection, and it gives us something along this line. And we eventually ruled out this idea because we thought that this is still not good enough, and you don't really want to test on a test database because eventually you're not testing the same thing that you would ideally want to test. So the next thing is that, oh yeah, now it seems you want to test the real things, let's use the real thing, but MySQL is the one that is most risky, so let's exclude that, but you do the rest. So you do the rest, so you run your test with MySQL database with a test instance of the MySQL database, but for the rest of them, you use the real one. And we even explore things like setting up this MySQL instance in a way that is very, very close to the DR database, which is like we set up a master to slave link here from the real one to the test instance. So that sort of like give you and make it a writable slave. So that sort of like gives you an instance that is almost the same as the test database, but not the real one. So you can tear this thing down anytime you want, and before DR, you just switch it back. So we talked to the DBA team, and they sort of like didn't like the idea. So yeah, I mean this is one of the viable approach. Risk-wise, it's also not that huge, but the DBA and ops teams do not like it. They still want to see whether we can test the real thing. So eventually we arrived in this whereby let's just use all of them, all the real ones, and data in the DR DB will have to be eventually replicated back to the production DB, because when you failover and failover back, then you will have to replicate data back. So you expect that whatever changes they make to the test accounts in the DR environment will be eventually arriving in the production DB, and we are hoping that there's no replication conflicts and so on. So, that's the main risk, like the test data in DR might cause conflicts when replicated back to the production DB. And so this is back to the same configuration that we saw in the original graph diagram. So again, back to the question, should we allow them? So yes, we want to allow them. And if you look at the trade-off again, like for the first one, do we allow writing to the DR database? Yes, let's do it. But what about the risk of failed DR failover testing? That's still an unknown, because we haven't really tried to run the test. So the moment we try to run the test, we encounter multiple issues. So one of the tricky issues is that some of the tables use auto increments for column for primary keys in the tables. So for those things, like if your test create a new record in the DR environment, and then somehow the production environment keeps on creating new records, right? Then you have conflict of IDs belonging to different rows, different contents, and when they try to replicate and convert, there will be a conflict, and then you can't really proceed. So insertion to those tables in DR environment will cause replication conflicts, and that's the big no-no, right? So of course there are solutions to that. So obvious one is that you can play with the auto increment, and auto increment offset to make, like if you have two data centers, you have like one with odd numbers and one with even numbers, so they will never conflict with each other. So you can still merge back. But again, our lovely DBA teams vetoed the idea, because you need to run a change of configuration in the current production database, which they hate to do. So and then also we were talking about like having multiple DR centers in the future. Like then what happens if you want to have a third one? Then you have to change the increment from 2 to 3 next time, right? So it's a bit troublesome and tricky when you think about that scenario. So we rejected the idea. And the next natural thing is that things we cannot insert, we don't insert to those tables, right? So we just avoid insertion into those tables. And luckily we found those tables, and they run not too many of them. And those tables are not so critical to the extent that we have to test them. We really have to test them in the environment. So we figure that if for those test cases, they're not the critical ones. So if they really failed in real life, we can accept that. Right? So we accept it as like, we take it as a trade-off. Like, yeah, maybe we don't run those tests. We can just run those tests that we can accept updates or insert into tables that have no auto increment columns, and we will be fine. And if any of those untested tests failed, product managers are okay with that, and we are all okay with that. And chances of those tests failing are also not that high anyway. So that gives us the so-called final proposal. But before that, there's another issue. So we declare that we don't run those tests, but it doesn't prevent any random people from, without knowing any context, to run those tests against the DR environments. So how do we protect ourselves from that kind of scenario? Like some random people trying to be like 100% test coverage for us and so on. So the solution turned out to be very simple. We used a different MySQL database user and with restricted permissions. So we create a MySQL database user that do not have insertion rights into those tables. So that gives us the guarantee that even if someone runs the test, they will fail. The test will fail because you cannot insert data into the tables anyway. So then we switch back to the original database user before we do the failover. And that seems to be a perfect final solution. So we use the real DR databases as in DR for testing. So no test database, yes. Same configuration as production, so we are testing the real thing. And we set up MySQL database, the database in DR and production as a master-to-master replication. So a bit risky, but that's what we're doing. So, and then we avoid doing insertions into tables that has auto-increment primary keys. So, and of course, we exclude integration tests that do this kind of insertions, which luckily is a small subset of it. And we set up a MySQL user that with restricted access to be sure that we are protected against those abuse. And with that, we can run end-to-end browser tests against DR while it is still in standby mode. So that's a great achievement. We have never done that before. So that actually gives us a lot of confidence in, like, yeah, it's indeed working. And we actually discovered quite a number of problems because we're building a new DR data center. So we use this to make sure that the backend components are still working nicely with each other. So coming back to the trade-off again, writing to the DR database seems to be low risk now, because replication may fail, but if it fails, we will know it now. Right? You won't have to wait until, like what we did the last time, until we are in DR, and we'll try to fail over back to the production, and we discover that the network we discover that the network link is not not working, right? So if there is an 8 hours lag in terms of replication back from DR to production, we'll know that now. We have monitoring to make sure that it happens. So in terms of test strategy and test coverage, we are, again, low risk because we are running most of the tests, except for those that does the insertions into the tricky the auto-increment tables. So to wrap up, there are a few caveats that you may have to pay attention to. So this solution is not perfect. Sorry, coming back to this. So we actually managed to get to the best side of both worlds, like low on both lists. So it's a pretty amazing achievement. So it's not like 100% perfect solutions. It doesn't cover all the aspects of DR available. So it only runs functional tests. It doesn't, and a little bit of network link testing between the two data centers for MySQL replication, but it doesn't cover some other aspects like network routing. When you come in, when the mediator, the middle layers coming into the data center, does that part still work properly, and some other stuff, but it's good enough for now. And it adds a little bit of a complexity to the failover plan because now you have to do extra steps to like restore the MySQL database user and do a bunch of other stuff. More steps to be performed, so yeah, you need a runbook to do it properly. So to conclude my talk, so it is possible to test the DR environment while it is still in the standby mode. And there's a trade-off between the risk of production failure versus the risk of a failed DR failover. So you need to make a decision on which one you favor more. And as a side note, avoid using auto-increment keys in a if you really prefer multi-data center support. So that will have solved some of our problems. So with that, that's the end of my talk.